All right, strap in, everyone, because today we're going deep on quantum positioning systems.
QPS.
QPS, yeah.
That's right.
We're basing this deep dive on an essay by Jurgo Schneepat.
Oh, very interesting.
And the essay explores this fascinating question.
Mm-hmm.
Imagine you're in a submarine, right? Hundreds of meters below the surface. Or maybe you're spelunking in a cave system that seems to go on forever.
Right.
In those situations.
Yeah.
GPS.
Forget about it.
Is a no-go. So how do you navigate?
Yeah, it's a problem.
Schneepat suggests that QPS could be the answer.
Interesting.
Using some pretty mind-bending quantum mechanics to figure out your location with amazing accuracy.
Wow.
And all without relying on those sometimes unreliable satellites.
That's really fascinating because it pushes the boundaries of what we think is possible with, navigation these days.
Yeah.
We all rely on GPS.
Oh, totally.
But Schneepat points out its reliance on satellites makes it vulnerable, right?
Yeah.
Buildings, bad weather, you name it. Even intentional jamming or spoofing, it can all mess things up.
For sure. And not to mention, GPS just isn't precise enough for some applications.
Right.
I was reading about scientific research that needs to measure, tiny movements in the Earth's crust.
Wow.
Or, military operations that require pinpoint accuracy.
Mm-hmm.
QPS could be a game changer in those fields.
I see. So we're talking about using the strangeness of the quantum world to find out where we are. Things like superposition, entanglement.
Yeah.
How does that even work?
Yeah. It's all about harnessing those unique properties of the quantum world.
Right.
Superposition, for example, lets a particle exist in multiple states at once until we measure it.
Okay.
It's like an atom is taking multiple paths simultaneously, which is a pretty wild concept to wrap your head around.
Yeah, definitely a bit of a mind bender.
It always makes me think of that Schrodinger's cat thought experiment.
Where
the cat is both alive and dead until you open the box.
Yeah, I see the analogy.
But I'm guessing we're not building feline navigation systems here.
No cats involved.
Yeah. So how do these quantum phenomena actually get translated into a positioning system?
Well, that's where atom interferometry comes in.
Okay.
It involves using ultra-cold atoms. We're talking chilled to almost absolute zero, and lasers to manipulate them super precisely.
Wow.
It's pretty amazing. We're talking about splitting the path of an atom, letting it travel, and then recombining it.
Mm-hmm.
And the really cool part is, any changes in gravity or acceleration along those paths, it'll shift the resulting interference pattern.
Okay.
And those tiny shifts, that's what QPS measures to determine location.
I'm trying to picture this.
Yeah.
Is it kind of like those ripple tanks they used to have in science class?
Oh, yeah, I know what you mean.
You drop two pebbles in, and the ripples interfere with each other, creating a unique pattern.
That's a great analogy. Instead of pebbles and water, though, we're using atoms and lasers to detect these super subtle ripples, you could say, in the fabric of space-time.
I like that. Ripples in space-time.
And because these quantum systems are so incredibly sensitive, we can potentially achieve levels of precision that are just mind-boggling.
So instead of signals from far-off satellites, we're basically using atoms to feel the forces around us and figure out our position.
Exactly.
That's incredible.
And it is pretty remarkable.
But I have to admit, it all sounds insanely complex.
Yeah, it definitely is cutting edge.
What kind of technology do you even need to do this? Are we talking massive labs, tons of equipment?
Well, you're not wrong. Creating and maintaining these ultra-cold atoms, manipulating them with lasers, measuring those tiny changes in the interference patterns, it all requires incredible precision.
It's almost like you have to build a miniature universe in a lab just to figure out where you are.
You could say that.
But with all this complexity, there must be some incredible applications for QPS, right? Beyond just working where GPS fails.
Oh, absolutely. This is where things get really exciting. Think about submarines navigating the deepest parts of the ocean, mapping the seafloor with incredible detail, or scientists exploring uncharted cave systems, creating 3D maps in real time, even in complete darkness.
Wow.
And those are just a couple of examples from Schneepat's essay.
He also mentions space exploration, right? Being able to guide spacecraft with pinpoint accuracy in places where GPS just can't reach.
Exactly. Imagine landing a probe on a distant moon or even a planet with centimeter-level precision.
Wow.
That level of accuracy could totally revolutionize our understanding of other worlds.
And what about applications here on Earth? Could QPS be used for things like monitoring glaciers or predicting earthquakes? The things that are currently impossible to do.
Absolutely. The potential for QPS in geophysics is huge.
Yeah.
We could study volcanoes, track groundwater flow, even monitor the stability of bridges and buildings with incredible accuracy.
It's like having a whole new way to see the world around us.
It really is.
Okay, this is all incredibly fascinating.
It is, isn't it?
But let's be real. Every new technology has its challenges, right?
Yeah.
What are the hurdles that QPS needs to overcome?
Of course, miniaturization is a big one.
Okay.
Right now, these systems are pretty bulky and expensive.
I can imagine.
We need to find ways to make them smaller, more portable, and more affordable if we want to see them everywhere.
That makes sense. It's kind of like the early days of computers, when they took up entire rooms.
Exactly.
But making something that relies on ultra-cold atoms portable sounds almost impossible. Are we talking about shrinking entire labs down to the size of a phone?
Well, it is a huge engineering challenge, no doubt.
Yeah.
But the field is advancing rapidly, and we're already seeing progress in miniaturizing some of the components.
That's promising.
The race is on to develop a practical, portable QPS device that can be used in real-world situations.
It sounds like we're on the verge of a quantum revolution in positioning and navigation.
It does, doesn't it?
I'm definitely eager to see where this technology goes in the future.
Me too.
But before we wrap up this part of our deep dive, let's take a moment to appreciate the insights Jurgo Schneppat offered in his essay.
Yes, absolutely.
He really paints a vivid picture of the potential of QPS.
He does. His work is a great starting point for anyone who wants to learn more about the future of navigation and the amazing possibilities of quantum technologies.
All right, we're going to take a quick break, but we'll be back soon to delve deeper into some of the ethical considerations surrounding QPS and explore what a world with widespread quantum positioning might look like.
Looking forward to it.
Stay tuned.
Sounds good. One thing that's really interesting as we explore this idea of QPS is to consider the broader implications of this technology.
Yeah.
One thing Schneppat touches on in his essay is how QPS could change our relationship with maps and navigation completely.
That's a really cool idea.
Yeah.
He even suggests that in the future, maps might become, obsolete.
Right.
Because QPS devices could guide us anywhere on Earth, underground, even in space.
Exactly. Imagine you're navigating a super dense city or a huge underground complex or a massive underwater cave system, all without ever needing a map.
Yeah.
Your QPS device would basically be like an internal compass,
I see.
guiding you perfectly to your destination.
It'd be like having a sixth sense, a built-in navigation system that can't fail.
Yeah, it's amazing. But, it does make you wonder. If we become so reliant on this kind of technology, would we lose our own sense of direction?
That's a great point.
Our ability to navigate using landmarks and spatial awareness, even just our intuition.
It's like relying too heavily on GPS today, right?
Yeah.
Sure, it gets us where we need to go.
Yeah.
But do we really, learn the places we visit? Do we build those mental maps that help us get around?
You're right. It's a trade-off.
Totally.
You get this amazing convenience and accuracy with QPS, but you might lose some of your navigational skills.
Yeah, and that sense of discovery that comes with figuring out a new place on your own.
Right. And, it's kind of unsettling to imagine a world where maps become relics of the past.
I know, compasses and sextants.
Exactly.
I mean, those older ways of navigating, there's a certain romance to them.
Yeah, for sure.
Like a sense of adventure, a real connection to the world around us.
And think about all the cool stuff we might miss if we're just following the most efficient route,
Right, exactly.
Those little unexpected discoveries, the hidden gems, the feeling of getting lost and then finding your way again.
It's all part of the adventure.
Exactly. And I think that's the real challenge, isn't it? As we build these incredibly powerful technologies, how do we hold on to that human element, that connection to the world?
That's a really important question.
And it's not just about navigation either.
Yeah.
Schneppat also asks how QPS could change how we see the physical world.
How so?
Well, if we can pinpoint our location so precisely, down to the centimeter, would we start to see the world as just a bunch of coordinates, like a grid of data points?
Yeah. Instead of an actual landscape of experiences.
Exactly. It's like reducing everything to numbers.
Yeah, it feels a bit cold, doesn't it? Like a mountain is so much more than just its elevation.
Right. And a forest is more than just a bunch of trees.
Exactly.
It's about the whole experience.
Yeah, the sights, the sounds, the smells, the textures.
Everything.
And I think there's a risk in relying too much on tech to experience the world
For sure. It's like how digital maps have already changed our perception of space.
Oh, interesting.
We can zoom in and out, see whole continents.
Right.
But do we really grasp how vast those landscapes are? Do we understand how everything is connected?
It's more like we're just looking at data points on a screen.
It's easy to get lost in the data and forget about the real world.
I totally agree.
It's like we're putting a filter between ourselves and the world around us.
Yeah, and yet I can't help but be excited about the potential of QPS. Think of the scientific discoveries we could make, the mysteries we could solve. We could explore the oceans, uncover secrets in ancient pyramids, even understand the Earth's core with this incredible precision.
I know, the possibilities are amazing.
It's all about finding the right balance, isn't it? Using these tools to learn more about the world, to explore, to connect with each other and the planet in meaningful ways.
Absolutely, and I think that's what makes this so fascinating.
Yeah.
QPS is more than just a navigation tool. It's a technology that could reshape our whole relationship with space, with information, even with ourselves.
That's a great way to put it. And as we move towards this quantum future, it's so important to have these conversations, to talk about the ethics of it all, and to make sure we're using it for good.
I couldn't agree more. It's been a really thought-provoking deep dive into QPS so far.
It really has. Thanks again to Jorg Oknapat for inspiring this conversation with his insightful essay.
Absolutely. His work is a must-read for anyone interested in the future of navigation.
Yeah.
And the amazing potential of quantum technologies.
We've covered a lot of ground, but there's still so much to explore.
That's right. And in our final segment, we'll dive into some of the specific ways we could use QPS.
Okay.
And what a world with this tech everywhere might actually look like.
Sounds good. Welcome back to the show. It's been quite a ride exploring quantum positioning systems with you all.
It really has.
We've gone from the mind-bending science to the potential impact this tech could have.
Yeah, it's not just about getting from point A to point B anymore.
Exactly. Schneppat's essay really shows the range of applications for QPS.
He does. It's pretty amazing.
We talked about navigation in, the toughest environments, but it goes way beyond that.
Right.
One area I found super interesting was geophysics.
Oh, yeah.
Using QPS to study the Earth in ways we can only dream of right now.
It's mind-boggling to think about.
Seriously. Imagine using QPS to make real-time 3D maps of underground geology.
Wow.
Tracking the flow of magma under volcanoes, even finding valuable mineral deposits with incredible accuracy.
It'd be like having X-ray vision for the planet.
Right. It could completely change how we understand earthquakes and volcanoes.
And potentially save lives.
Exactly. And I was reading about how QPS could even be used to monitor glaciers and ice sheets, giving us vital data on climate change.
The possibilities are huge.
And it's not just about understanding the Earth, it's about managing our resources better, too.
Absolutely.
Imagine using QPS to, optimize groundwater extraction.
Making sure we're using this precious resource responsibly.
Exactly. It feels like we're on the edge of a whole new era of exploration, not just of physical space, but of knowledge.
It's a really exciting time to be thinking about these things.
And who knows what other applications we might find as we explore the quantum realm even further.
It makes you wonder what other impossible technologies might be just around the corner.
Right. But before we get too lost in the future, I want to come back to something we touched on earlier. The ethical side of QPS.
Yeah, it's really important.
Schneppat makes it clear that there's potential for misuse. If QPS can track location that accurately, it raises serious questions about privacy and surveillance.
You're right. Imagine a world where every step you take could be recorded.
It's a bit unnerving to think about.
It is, and it's a conversation we need to have now, before this tech is everywhere.
Absolutely. How do we make sure people have control over their location data? How do we prevent this technology from being used for the wrong reasons?
It's a tough question, no easy answers.
It really highlights the need for collaboration, bringing together scientists, engineers, ethicists, policymakers, even artists and philosophers.
We need everyone at the table
to figure out how to navigate this new world.
To approach this technology with a sense of wonder, but also with caution.
It's not just about what we can do, it's about how we use that power.
I think that's the key takeaway here.
Well said. It's been an incredible deep dive into the world of quantum positioning systems.
I've really enjoyed this conversation.
From the science to the applications to the ethical questions, it's been fascinating.
It's a technology that could truly change the world.
And it's up to all of us to make sure those changes are for the better.
A huge thank you to Jorgo Schneppat for his essay.
Absolutely. It was the perfect inspiration for this deep dive.
His work is a must-read for anyone interested in the future.
And to our listeners, Thanks for joining us on this journey into the quantum realm. Until next time, keep exploring, keep questioning, and keep diving deep.
See you next time.